Okay, so we're going to be looking at quadratic vocabulary, particularly the vocabulary that goes with graphing. So the first question is, why is this called quadratic in the first place? Because the x is squared. And this is the simplest of all quadratics, and the simplest of all quadratics is called the parent graph. The simplest one is called the parent graph. This is the parent graph for a quadratic. Well, what's it going to look like? Well, one way we can tell what a graph is going to look like is to make a little XY chart. And if x is equal to -3, and this tells me to square it, what is -3 squared? And if I plug in a -2 squared is 4. And if I plug in a -1, -1 times -1 would be +1. What happens when you square 0? And if I plug in a 1 and square it, and 2 squared, and 3 squared. Did you notice that these numbers go down and then these numbers go up? And that we have the same numbers? Okay, what would that look like on a graph? Unfortunately, I don't have any graph paper to give you, so we're going to have to make the best sketch we can. One, 2, 3, all the way up here at 9. Two and 4. -1 and +1. 0, 0. Now, are those all the points on my graph? No, those were just the ones I picked out to put in my table, but they are certainly enough to tell me what the graph is looking like. This curves down here at the bottom. It's not pointy like an absolute value graph. How far up is this graph going to keep going? I put an arrow on the end. What does that mean? It's going to keep going up and up and up and up. Oops. And this U-shaped graph is called a parabola. The graph itself, the U shape, is called a parabola. Not a parabola, parabola. Okay, and so this is what the parent graph looks like. What does that mean, parent graph? It means all of the quadratics are going to have this basic shape. Some of them may be wider, some of them may be skinnier. Some of them may have this point right here in a different place. This point right here is called the vertex point. And whenever we look at a graph, we always like to talk about the domain and the range. What is the domain of this graph? Do we remember the word domain from earlier in the year? Domain goes with? Now, this parabola is pointing up, right? But as it's going up, it's also spreading out to the left and the right. How far does it spread out to the left and to the right?
3.
Nope. The arrows on the end are telling me it's not. This graph doesn't stop here. That's what I'm saying. This arrow is not going straight up from 3. This arrow is spreading out, and it would go to 4 and 5 and 6 if I had put more numbers in my graph, my table. And so how far is it going out to the left and the right? Infinity. And so we usually say the domain is all real numbers. Or we can say that the domain is negative infinity to positive infinity.
All real numbers is any number you can find.
Yes, including positive numbers and negative numbers and fraction numbers. Real numbers are all the numbers except for the numbers that have I. We have complex numbers that have I in it. All the rest of them are real numbers. What about the range? The range is the Y value. The arrows on the top tell me it's going up and up and up, but does it go down and down? Does it have a bottom point? Where is the bottom point? The Y value of this point is 0, and so Y is greater than or equal to 0. I personally like to use interval notation more than inequality notation, and so the interval notation would be it starts at 0 and goes to positive infinity. Is that coming back to you from way, way, way back at the beginning of the year? And all quadratics are going to have this basic U shape. And there's some vocabulary we need to have to look at our parabolas. So if you happen to have 2 different colors, it might be useful so that you can have your X and Y axis in one color and your parabola in a different color. And pretend that that's a perfectly U-shaped graph. You have to use some imagination here. I did better on my first graph. This graph is supposed to be symmetric. If you draw a line down the middle, the 2 halves are supposed to match. Now my diagram was not that great, but that's what it's supposed to look like. And this line that goes down the middle is called an axis of symmetry. The axis of symmetry goes down the middle and divides the parabola into 2 halves, and the 2 halves should match. They would match better if my drawing was better. This point is called the vertex point. Oops, I'm off the page. In this particular parabola, do you know why I would call this point the minimum point? Because it's at the bottom. And so this is on this particular example, the vertex is the minimum. What would I call that point right there? What do I call this point and this point? The x-intercept, we're going to add that in there. This point and this point, those points right there are called x-intercepts. That's what you are finding when you solve by factoring or the quadratic formula or completing the square. You're finding the x-intercepts. When you solve the equation and find the solutions, you're finding the x-intercept. And the solutions can also be called zeros or roots. So x-intercept, solutions, zeros, or roots are all the same thing. They're the same number. They may be written in a different format because we usually write x-intercepts as points with parentheses. And we write solutions, x equals a number. But it'll be the same number that we had in our x-intercept. Sometimes we might have a graph. Let me see if I can do a better job at making it look symmetric. That looks like this. What's this line down the middle called? Does this axis of symmetry go through the vertex point? Does it go through the vertex point? Oh, where is the vertex point? What's that point called? But this time it's not a minimum. This time it's at the top of the graph. And the graph is called a maximum. That point is called a maximum. What's this point called? What are these points called? X-intercepts. How many do we have? And so that's why it's incorrect when you're solving to say that x equals 5 or x equals -4. It's not an or. X equals whatever that number is and x equals this number. It has two solutions. X-intercepts. X-intercepts are the same as solutions. Solutions are the same as zeros. Zeros are the same as roots. All four of these numbers are talking about these two places on the graph. Okay, so now I'm going to switch over to a pre-made graph, so you might want to just look up here instead of trying to copy this down exactly. Okay, you see this line right here? What is that called? Now, this axis of symmetry has an equation. This axis of symmetry is going up and down. Do you remember the slope of a vertical line? Do you remember that the slope of a vertical line is undefined? So we can't put the equation for this line in y equals mx plus b form because the m is undefined. Straight up and down lines have the equation x equals a number. Where does it cross? The x-axis? That's where you get the number. What is this point right here called? Vertex. what is the coordinate that goes with this vertex? And do you see this one shows up right there? Because the axis of symmetry goes through the vertex. Now, is this point a maximum point or a minimum point? And does it have a minimum point? Because this should have arrows on the end. Now, it doesn't say maximum point. What does it say there? And that means the y value at that point. How high does it go? It goes up to 4. What is a root? Well, let's do it this way. What are these points called? And so what are they? The x-intercepts are at -1 and 0, and at +3 and 0. When we write the x-intercepts, we write them down as points. But this, and this are the same thing. Except when we write it down as roots or solutions, we write it down like this. And when we write it down as zeros, we have those same numbers, but we don't write it. And we have one more blank here. What is the y-intercept? And so the y-intercept we write as a point. Of this just formatting. Let's do one more. So, do you agree that this is easier than solving equations? Okay, so here we have another one. Let's start off. One of the key points to always be aware of is the vertex point. So can you tell from where you're sitting what the coordinate of that vertex point is? So this is 3, -8. And is that point a maximum or a minimum? Do you understand we can't have a maximum and a minimum at the same time? It's got to be one or the other. And what is the maximum value comes from the y value of the vertex point. How low does this go? -8. And so, and that's the y value that goes that low. This dotted line, we usually use a dotted line for the axis of symmetry. If I folded it on the axis of symmetry, the two halves would meet. You can see this better from the pre-made graph than the ones that I was drawing. And so this is a vertical line, so it's x equals a number. The axis of symmetry has to go through the vertex. That's where you get the number for the x equals 3 axis of symmetry. What are the x-intercepts? Can you tell? And the roots are the same number, just written with the equal sign instead of in the point form. And can we tell what the y-intercept is? On my paper, I put the point on here so I could tell, because sometimes it's getting real close and it's hard to tell. And so the y-intercept is right there. So, one final thing. Here are your vocabulary words.